I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us for today's presentation, MSDN Webcast, Visual C# 2010 Soup to Nuts, Part 3, Class Libraries. Now it's my pleasure to introduce today's presenter, Bill Steele, Senior Developer Evangelist for Microsoft. Bill, you now have the floor.
Thank you, Sydney, and welcome to Part 3 of this C# Soup to Nuts webcast series. Today we are talking about class libraries, and we're going to have a little bit of background about what a class library actually is. So our agenda today kind of starts off at the very top level of what an assembly is. An assembly is a way we actually architect a .NET-based application, and in particular C# here. And we'll take a look at what's inside an assembly. We'll then move on to see how we can organize our class libraries through what we call namespaces. We saw a little bit of that last week, first week, I'm sorry, and then we'll drill down into some of the provided namespaces that come with the .NET framework, specifically what we call the system namespaces. There is the root system namespace, which we'll take a look at, and then we'll take a look at some of the sub-namespaces under the root namespace, which I have labeled here as system.star namespaces. And then lastly, we'll wrap it up by looking at building our own class libraries and organizing them within their own namespaces. So starting off today, we need to understand how we actually organize and build an application within C#. When we build an application in C#, what we actually wind up doing is taking our code that we type into the whatever text editor or application designer we use, in our case Visual C# Express. We take that code and we run it through what's called a compiler. And a compiler will take your code, your text English-based code, if you will, and converts it into a language that the computer can understand. Generally, classically, I should say, a compiler would convert it into what we call machine language, or if we were to try to read it, it would be called assembly language. In that case, the application would then be executed directly on the native hardware, and that machine language would be understood directly by that CPU that's in that computer. Now, in a more modern time frame, we've over the past 15, 20 years or so, a new paradigm has come out where instead of actually writing code that actually runs directly on the CPU, we actually have an intermediate step. And that intermediate step is designed to help us take full advantage of the equipment that we're actually running on. It also does a couple other nice things for us, which I'll describe a little bit later on. But in the .NET framework, the way this works is when we build an application in C# and we compile it, we actually compile it down into an intermediate language called IL. And this intermediate language is very similar to an assembler language that a native computer would run. However, it has a few extra special features. And that code then gets later on recompiled into the pure machine language that's actually run on the actual machine it's running on. Now, the first benefit that we get by doing this is that instead of you building an application and compiling it for a particular machine, with intermediate language you can actually compile it so that it can run on multiple machines. As long as each machine has its own sub-compiler, the secondary compiler that actually takes the intermediate language and compiles it to its own local, you wind up actually getting this ability to write an application on one platform and actually executing it potentially on another platform. But in reality, what we actually see is that there are so many different types of computers that have different types of equipment and things like that on board, different types of CPUs and stuff. What you actually wind up with is the ability of the compiler, the lowest level compiler, to actually optimize the code that you've written for that particular machine that it's running on. And that turns out to be a real benefit for us. Now, in addition to having this IL code inside of this assembly, what we also have is something called metadata. And metadata is literally data that describes additional features or aspects of the code that we're running inside this application. Now, interestingly enough, one of the other benefits of running code through a runtime environment that understands something like the intermediate language is that you can actually apply attributes or additional sets of requirements or hints, if you will, about how an application should run in an application without having to resort to adding additional code to it. So, for example, if we're running in a secure environment, maybe there is a requirement for a certain level of access to call particular functions. Well, we can actually describe that in data that gets embedded into the compiled assemblies, and that when the runtime actually executes this code, it can actually check to see that those conditions are met prior to executing that code. In fact, it's even prior to even compiling it in some cases. And then that's an interesting aspect of of an assembly from the .NET world. And then we have this ability to manage, if you will, the code way beyond what we could do if it was a natively executable code. So we can apply different criteria to it or take some different actions. And that's some really interesting things that we actually get with an assembly. Now, an assembly, if you look at it just as a base file on a computer, will have the extension either exe as an executable program, or it'll have an extension DLL, a dynamic link library. Now, classically, DLLs were the file type that you would use to store additional bits of code data in that wouldn't be the primary entry point of the app, but would be secondary files that you use to have additional functionality that you would use in there. And all of Windows is built around DLLs. So the DLL extension happened to be the one that we chose as well for the assemblies. And it turns out that because the assembly actually contains intermediate language and not actual native language, we can actually use a tool to actually open up that assembly and see what's inside it. We can actually view the metadata or view the intermediate language directly. Now, I'm going to use a tool called ILDASM, which is the IL, or Intermediate Language Disassembler. So if you're familiar with compiling applications, one of the ancient tools that we used to use was called an assembler. Well, you can actually write code in assembler and compile it to native code. And just the same way you can go to native to, you can go from your assembly to native, you can actually go the reverse way. And this is kind of what we're doing at a little bit higher level. In this case, we're going to take the assembly and we're going to open it up and actually look at the intermediate language inside of that. So let me start off the day by actually going out and doing a quick little demo of the ILDASM tool, because we're going to poke around with it a couple more times in this session. Now, this tool isn't generally installed with your development environment. It's actually, in fact, part of the higher-end versions of Visual Studio. But it is available out there. If you want to use it and play around with it, feel free to. But like I said, it is not included with the C# Express edition. So when I move to the next slide, it's going to take me out to my demo, my view sharing demo. And my computer screen is set to 1024 by 768. And if your screen is set to that or higher, you can press the F5 key to maximize and see my entire screen. And while we're doing this, feel free to ask any questions by just typing them into the Q&A panel there. And when we come back from each one of the demos, I'll look at all the questions in the queue and answer them verbally here. So 2 weeks ago, we built our first application. It was a very simple little console application. And then we introduced last week the Visual Studio Visual C# 2010 Express Edition. And this was the console application that we built. So if we go ahead and run this, you'll remember that it simply types out the text, "Hello World," and it simply sits there waiting for me to press any key. So as I press any key, the application exits. Now, this application is a very, very simple application. And if we actually go over to our project, we can actually go to the properties of the project and see a little bit more information about this application. We can see that the assembly name is called Console Application 1, and it has the default namespace Console Application 1. As a matter of fact, when we look at our code, we see in our code the namespace is Console Application 1. Now, this namespace is actually kind of interesting. It's important for humans, but it's totally unimportant to the actual computer itself. And you'll see that when we actually look inside the code, there is no reference at all to this namespace called Console Application 1. When we go back over to our application code, you also see that we have this additional button here for assembly information. And when I open that up, you'll see that we have the title of our application and some additional metadata describing some of the features of the app, properties of the app, specifically, who the company is that wrote it, what the name of it is, and if there's any copyright information. A couple of the other key features in here, though, are information about which version this is and which file version this is. And these are actually key for helping us differentiate different compiles, if you will, of our application. And then there's some other additional metadata in here that will actually get stored in there as well. So that shows some of the assembly information. Now what I'm going to do is I'm going to pop over to my command prompt. And in my command prompt, I'm actually using one from the Visual Studio 2010 environment, the 2008 environment. When you install any of the higher-end tools, like Visual Studio 2008 or Visual Studio 2010, the full editions, you actually wind up getting some additional tools under a menu called Visual Studio Tools. And the one I'm actually launching is simply the Visual Studio 2008 command prompt. The reason I'm actually launching this is because this sets up the path and all the other information to the .NET Framework binary files, where, if you remember, we did the CSC compiler in the first first webcast. The other tool that I'm going to be using today is the ILDASM tool, which is also in that same directory, and this just sets the path, the DOS environment up for us correctly. So I'm actually in the directory where this application gets compiled. So if I go ahead and build this and go back over here and get a directory of that, you'll see that we now have our latest version of our console application. And what I can do now is in our application, I can simply use this tool called ILDASM. So it's ILDASM, and then I can just type in the console application 1.exe. And as I type that in, that brings up this tool that allows me to compare side by side my code with what's actually in the assembly. And as we drill down into this, you'll see that this is console application 1. We have a class called program, and here we can see the console application 1.program class. And then underneath that, we simply have a single method called main. And our main is a void string, so you can see it returns a void and it takes a string array as a parameter. And if we drill into main, we can open that up even further and see that as we follow through here, we'll see that the code is spot on what we're actually doing. Interestingly enough, it's done a little bit different. What we have here, right here in this section right here, is the actual intermediate language itself. And around that is what we call the metadata. This metadata and there are some other metadata throughout the rest of this assembly actually help describe how this application is actually configured. So, for example, we know that the main method here in our C# code is the actual main method in our assembly because when we look at our assembly, we see the .entryPoint attribute applied to this block of code. So this block of code is marked as the entry point. So whenever whenever the .NET Framework tries to launch this code, it will look for this attribute called entry point and know to begin execution here, this first instruction. It also has another attribute specified that lets us know how many elements are needed for the stack space. In this case, there are 8 bytes basically needed for our stack. And in fact, we don't do much on the stack except use it for one call. We then start off with our very first intermediate language instruction at position 0, which in this case happens to be a no-op or no operation. So if you're familiar with the assembly, that's a common way of basically saying, hey, skip ahead to the next line. Now, technically, you can actually remove these and the code will actually work identically. It's just that a lot of times a compiler will stick those in for various reasons, whether to pad it out for memory spacing or whatnot, but for whatever reason, the compiler decided to put in a no-op here. You'll notice that there's actually another one in here as well. Then the very first command that we have here is this console.writeLine, where we're actually specifying the text hello world. And the way this actually works in our code is that we actually have a method called loadString, and we're loading this string called Hello World up onto our stack, and that's actually basically creating a pointer to this string that we have right here in memory. And then we call a method within the .NET framework. This is the MS Core library that's contained within the actual namespace called System, and the class is called Console. And then the last thing is the actual method that we're calling, giving the string that we just loaded onto our stack. So here's the string that we're passing into it. So in this case, we have a right line Hello World, and you can see our code is exactly doing that. It's loading Hello World onto the stack and then passing that into the right line method. Then we again hit that second no-op, and then we make another call back into the .NET Framework's MS Core library, calling the system.consoleKeyInfo class. And in this case, it's mapped through system.console method called readKey. So here we have our readKey method, and again, we have our readKey method in our system.console namespace. And then once we're done with that, we then go ahead and clear the string that we had on the stack. We just pop that right back off to remove that, and then exit out of this main method, and that's exactly what happens here. Notice that some of these instructions really don't match up to what's in here, but they are required for each type of function call that we're dealing with. So this gives you a little hint at what's inside of this assembly, and you'll notice that, like I said earlier, the only reason that we have the namespace in here is actually to clarify the class names. So you'll see that we have console application 1.program. This console.application1 is the namespace containing this entire class. So we'll see a little bit later on how we extend this out. So with this, we can then go through here and basically take our application and learn more about it. So we can see how the code is actually executed. As a matter of fact, if I want to, I can even look down here at the bottom and see some additional metadata about this. So here's our .assembly information. We can also look at the manifest inside of here and actually see what kinds of additional metadata this assembly has about our application. So in this case, it's the very first line in here is basically referencing an external library called MS Core Lib. Whenever you build a .NET-based application, you're probably going to use some kind of a code from the .NET framework itself, and that is all referenced through this external reference called MS Core Lib. Here's just a unique public key token for this application to help it validate itself. And then it can actually see some information about the actual console application 1 assembly itself, and we can see that there's attributes about which version of the .NET framework it's running on. And if we scroll over here and take a look at that, you'll see that this is the .NET framework version 4.0 in our case. So that's embedded in there directly. And then you'll see some other attributes, for example, that copyright information that was in there and who the author was. And there's that copyright string right there that I was talking about. So here you can see that's the assembly copyright attribute is actually stored right inside this assembly as well. And then lastly, down here we see another section that actually has some information about the physical aspects of the file and how it's actually organized. So in this case, it's a 32-bit application, and here's a file alignment with an offset of 200, for example. So this just shows some interesting little bits of information about that. Not much you would do inside of here. You would generally edit those inside of the Visual Studio environment instead. And then everything is contained within this one console application 1.exe, which is the actual assembly itself. Now, I could load things up as a DLL as well, and you would see a DLL extension, and generally they would be exactly the same, except for the fact that as DLL generally doesn't have an entry point, which that would be the primary difference between the two. Okay, so let's pop back over to our slide deck, and let's move on, and let's talk about those namespaces themselves. What is a namespace? A namespace is simply a way for humans to be able to understand the organizational structure of an application. we put code in namespaces to help categorize it, to logically separate it from other types of code. Generally, a company might have their own set of namespaces, and within that namespace they might have maybe divisions within their company, and then within the divisions of that company they might have the types of applications that they're dealing with or the departments. So you get a hierarchy that you can drill down into to get to specific sets of functionality that you're interested in. So let's say, for example, you had an accounting package that was in your, accounting department of company A. So you might have company A dot, accounting dot, accounts receivable. And then within that you would have the functions for accounts receivable. And that's the way you would logically lay that out. And you separate each one of those different levels of the namespace through a period by simply putting a period in between each one. And that helps us actually organize those, and it helps you very quickly locate, bits of code. Now, like I said, technically under the covers, there's really not much, there's nothing unique about, there's nothing that's physically done to the code to create a namespace. It's simply an extension of the class name, if you will. So if I had a class called foo, the Microsoft namespace might have a class library called foo, so it would be Microsoft.foo, and that would be the entire namespace. So it helps make it more unique, if you will. Now, the very top level namespace within the .NET framework is one that you're going to use more than any other, and it's called the system namespace. The system namespace contains all of the basic functionality that the .NET framework provides. In fact, it contains the very basic object class, which every object within the .NET framework derives from. The object class is actually basically the granddaddy of all objects. And everything that you deal with within the .NET framework is going to be built from an instance of that object class, including the very simple types like an integer, or string, or an array, or any of the simple types. Those types of objects all derive from that base class called object. It's interesting to think about that. If you're familiar with other languages on other platforms, they generally have very simple types, and then they have an object type that everything that's complex derives from. In the .NET world, we're a little different in that we made very simple so that everything is everything is an object. So let's go ahead and take a look real quick at the actual system namespace and see what kinds of things that are provided for in there. Back over to my sharing machine here. I had a window I didn't know was open. So here's my sharing machine. You'll notice that when we build our application in C#, it automatically adds this using system namespace here. It also adds some additional ones, but at this point we're not going to use browse into them just yet. But the system namespace is the key one that we're looking at here. If I type in the word system and hit the period key, it brings up a list of all of the types of functionality that's available within this system namespace. And as I scroll down through here, you'll see that there are all different types of things that I can do. And in fact, you'll also notice that each one has its own little icon next to it representing the type of object or the type of functionality that it is. So when we look at this little lollipop thing here, this indicates that this to me is an interface. So this is the classic interface symbol, which we'll describe later on in a future episode. The next one is actually a box that has basically logic boxes under that. This indicates to me that this is a class of some sort. The one below this actually is an interesting one. It's a suitcase with a box inside of it, which basically means this is some kind of an event mechanism, or what we call a delegate in C#. So whenever something happens, this guy can call into some other code to help handle that. And as we go down through here, you'll see that there are all different types of them. In this case right here, we have instead of a method call, it's some kind of an organizational thing called a struct. It's basically like a class for basically storing data. And the last one that I want to point out are these little ones with the curly brackets. And the curly brackets actually indicate this is an additional namespace. You'll notice that we have namespace and then curly bracket, close bracket in our code. Well, this is kind of indicating the same thing. So system.componentModel contains additional data about other namespaces. So this is a further drill down into this namespace. Now, in our application, we're using these two console methods. So we have a console write line and a console read line. And if we actually look at our code, we'll see there is a console class here. So the icon indicates a class. And that class actually contains additional functionality within it of specific methods and properties and events. And that's what you see here. So we have our methods here. We have our events, and this is an event that comes back, and these are properties that we have set. So these are the types of things that you can do within this class, and this class is actually stored in this system namespace. So this is shows you the hierarchy of that. And you'll notice that when we look at this class icon, you'll see that there are all kinds of classes in here. So in this case, we have some enumeration classes. We have some exception classes. Here's a garbage collector class. There are all kinds of classes that help define what kinds of objects in here. The other thing that you find in here that you're going to use quite a bit of are what we call types. In this case, we have this structure that's an int16. This is an object, if you will. This happens to represent a 16-bit integer. Here's a 32-bit integer and a 64-bit integer. There are other types of those inside of this class, and we would use those generically throughout the application. One of the beauties of the way we organize things within the .NET framework is through this mechanism that we call importing or using. If I have a set of code within a namespace and I want to use that code, I simply use the using statement in C# and specify which bit of code I want to use, or which namespace I want to use. And this allows me to basically start typing in commands that are, or methods or classes or whatever, start utilizing those within this namespace without having to qualify every line of code saying, hey, I'm using this system namespace. If I didn't have this line here, if I commented that out, I would have to type in, you'll see actually Visual Studio complains right away that it can't find this console class. But if I fully qualify it, it immediately corrects itself and says, oh yeah, okay, there it is. What we're doing here with this using statement is we're basically saying, I want to use the system namespace throughout the rest of my application, and don't make me type it in every time. So if I uncomment this line, you'll see that red squiggly down here will actually go away. It went away because it knows where that system namespace is. So technically, this console and the system.console are identical. It's just that this one, the bottom one here, is actually using this alias reference, if you will. It's preloading it, if you will, whereas this one is actually fully qualifying the name out. I can use either one that I want to, but remember, here's an example of one that's actually pretty long, system.collections.generic. Within that namespace, there might be a bunch of other functionality underneath there, and it would get very tedious typing in those every single time. So by using the using statement, we can actually cut back on the amount of code that we actually have to physically type into our application. So that's a very quick example of a simple namespace, the system namespace. Let's go back over and look at our code. Our slide deck here. And let's take a look at some of the other namespaces that are available. Now, in our application, we built a very simple Windows console application. And that used the system.console namespace class. In our previous examples, in the first and the second episodes of this webcast series, we've also built a web app and a Windows app. And the Windows app was built using a class library called Forms that was contained within the system.windows namespace. And we built a web page using a class called Page that was in the system.web namespace. Those are different sets of functionality that generally you wouldn't use inside of a console-based application. And therefore, there is no referencing, there's no IntelliSense or anything like that to allow us to use that functionality. If I wanted to use that secondary namespace, though, let's say, for example, I wanted to add a Windows Form style function call to my console-based application, I actually have to add a reference to my application and tell it I would like to use this system namespace in this other, this class library in this other system namespace. So we're going to add a reference to that. And then what we can do is say, okay, now that I have that and I want to use that, I can add a using statement at the top of my C# code, just like we saw the others, and directly reference any additional code or class libraries within that new namespace. The types of namespaces that are available in the .NET framework, there's just hundreds and hundreds of them. Some of the basic ones that you're going to use are going to be like the ones we used already, the system.web and the system.windows. But there are additional ones that are going to be very, very helpful. For example, if you're dealing with any type of data in your application, you're probably going to want to use the system.data or system.xml namespaces because they contain class libraries and bits of code, functions and stuff that help you utilize, for example, an XML document or a database, data type. So those are some of the interesting things that you could, find in those namespaces. There are, like I said, hundreds and hundreds of namespaces out there that you can actually utilize to, build your applications. And some from the very, very rudimentary, TCP/IP communications, all the way up to very high-end advanced stuff like, transmitting an XML document from one server to another. So let's go ahead and pop back over to our code and take a look at some of these other namespaces and how we actually reference and use them. So back over to my demo here. Now in this case we have our console, but let's say I wanted to go ahead and display a standard Windows form style dialog box within this application. Because this application doesn't actually have the system.windows.forms namespace referenced, I have to add it using this references folder, and I just right mouse click and choose add reference. I can then go over to the .NET framework and scroll down here to system.windows.forms. Let me get down to system.windows.forms. They're not alphabetically sorted here. Let's try that again. System.windows.forms, so there it is. I can simply add that reference, and you'll see that appear now over in my references for my application. I can then go ahead and type in and either start using that reference directly. So in this case, I have to fully qualify it since we're not using the using statement. System.windows.forms. Let's just do a simple message box. Show hello world. So here I've created a very simple message box. We'll go ahead and run this code. Now it's waiting for me to press any key before it displays the message box. So if I hit a key, now I get my hello world dialog box, and I can hit OK, and the application exits. Now if I wanted to, I can actually shortcut quite a bit of this by using the using statement. So using system.windows.forms. I can then remove it from here and rerun the application, and you'll see that I get essentially exactly the same application. In fact, underneath the covers, the code is identical, the IL code. And we can see that here by just opening this back up. We can drill down into the code and see that in our main void, we actually have our hello world load string into the right line. We have the wait key that we had before, and then we have another load string hello world. Interestingly enough, we could actually get rid of these two, and this call should still work just the same. That's an interesting thing that we can do here. We can't really edit this within this tool set, but technically, if you remove that, since it's the same string, we could reutilize that. And then the last one is we're actually calling into the system.windows.forms.dialog class library here to actually tell the system to display this message box with our string in it, and our string is the same one we did. So you can see here that this just by looking at this code, we can see just a little bit of inefficiency here that maybe we could get by loading this into a variable and displaying it twice. And that's just one very simple example of something that you could do here. Some of the other namespaces that you might be able to use or you might want to use, if you just add a reference, you can actually see all of them all of the different namespaces that you can use. So, for example, maybe you wanted to use, for whatever reason, some Visual Basic functionality. You could simply add the Visual Basic reference to your C# code and start using it. There are a couple cool handy utility functions inside of Visual Basic that are real handy to have inside of C#. Some of the other ones that are pretty important, system.data, I talked about that earlier. System.data.link. We're going to talk about link in the future episode, but this is a really, really interesting library that allows us to make database or data queries against any type of data. Another one that's kind of important is the system.xml namespace. The system.xml namespace allows us to use any type of XML functionality, so an XML document, or let's say we receive a document from the internet that's in an XML format. We can then open it up and process it with this system.xml namespace. And there's just all kinds of other namespaces. Generally, Microsoft is going to have their own custom libraries as well, and those would be contained within Microsoft.namespaces. You'll notice that there's quite a few of those. So whether you're doing Office functionality or wanting to deal with the environment, there are just all kinds of them built around the Microsoft namespace. And then all of your code that's in the .NET Framework are going to be built around the system.namespace. Okay, back over to our slide deck here. And don't forget, feel free to ask any questions if you have any into the text box over here, into the question answer panel there. So now you've seen how class libraries are organized within the .NET Framework itself, what we call the base class libraries. But you can also build your own custom class libraries. And the way you do that is you basically set up your own namespace and your own class structure. And then from within that, you can go ahead and define any functions or functionality that you need within classes in that namespace. Again, just like we did in our own code, you can add references to that to utilize other namespaces. Or if you need if somebody is going to use your class library, they would simply add a reference to your class library, just the same way I added a reference to the system.windows.forms namespace. And then again, just the same way that we use the system namespace within our code to get to the message box functionality by using the using statement, we can do the exact same thing with any custom code that you've written. So you can add a reference to your class library, put a using statement to your namespace, and then start using it just as if you were using a system namespace. So literally just start typing in the class name, for example, and it'll pop up and allow you to start using it. So let's go ahead and finish up today by taking a look at building a very simple, quick custom library and class library and seeing how we can use it in our own code. So back over to my sharing. So now we have this hello world. And in our hello world, we have the console where we're actually writing the text hello world. We have a message box where we're actually showing that as well. Let's go ahead and create another class. I'm just going to add a new file called class. And we're just going to keep the default name of class 1 just to make it simple here. So class 1, notice that the namespace for our application is console application 1. And when we built our application, it was called console application 1. What I'm going to do is I'm actually going to change this to something else. I'm going to make two different levels of classes here. The first one I'm going to call this we'll call this my code. And then I'm going to call this class my class. So I have a class file that I'm building that's going to contain my code. And I'm actually going to make one more attribute on here. I'm going to make this public so that everybody can create an instance of this without trying too hard. Now that we have that, we have two different namespaces. So again, if I want to use this, what I'm going to have to do is add a reference over here. Now, in our case, since it's actually in the same project, technically we don't have to do this. I could just go ahead and drill down through here and find this if it existed, but it's not going to exist because it's actually in the same solution. So all I have to do is simply start using it. Now, let me go ahead and add a method to this real quick, and let's do a public void say hello method, and we'll just do a console.writeLine hello. So our application is simply going to spit out the text hello to the console window. this custom library code is. And then over here, what I can do is, let's go ahead and move this. Let's go ahead and put this call right inside here in the middle. I'm going to create an instance of this guy. So my code, basically what I'm going to do is I'm going to say using my code. Okay, so that's using this new namespace that I've created here. And then from within that, I can say my class, we'll just call this C equals new my class. So I've just created a new instance, instance of this class here, and then this class should contain a single method called say hello, in addition to some of the basic functionality. So here's the say hello method. And now when I run this application, we're going to get hello world on one line, and then this code is going to execute, and that code is actually going to say hello on the second line after hello world. And then it's going to pause and wait for us to press the key, and then lastly show the dialog box. So if I run that, you see I do get the hello world and this secondary library that has the hello text by itself in it, and it's waiting for me to press a key. When I hit the key, I then get the dialog box. So I have my primary library calling into a secondary library of code. Now what's interesting about this is I can actually take this a step further and actually create another namespace. So my code subcode. So in this case I have another namespace. Notice how it's separated with the dot there. And let me just go ahead and copy this and paste that into there. So I have my class again. Okay, but in this case, it's under a secondary namespace. So if I wanted to use this, I could actually hit the period key, and you can see I have a secondary namespace for subcode. And because the same class exists, the same class name exists, I can actually make that again. Let's do my subclass code. If we go back over here, we'll see that that's starting to fail because it can't find the name my class in there. Instead, it only sees my subclass. So in this case, let's do a using my code, and now it's found that my class method. Now this is interesting. This actually points out one interesting thing here. The way Visual Studio works is it actually looks for all of the code that you're referencing in all of these references that you have up here. It looks for a class called my class. No matter what it's called in the namespace, it's just searching for one. It's drilling down through there and trying to find the closest match to it. If I go back over here and I have my code and my subcode, and I go back and I change this name back to class, it's going to actually report another problem. It says, hey, wait a minute, I now have an ambiguous reference between this because there are two classes called my class, and you're referencing both of them. You need to differentiate this somehow. And the way you would differentiate it is by simply saying, subcode dot. Basically, you would identify which namespace it is. So it's mycode.subcode, and then you do the same thing here, mycode.subcode. So in this case, you would have to fully qualify it so it knows exactly which one you're referring to. And you'll find this often in a lot of cases where it's very often where you have the same class name in two different libraries that you're referencing. And when that's the case, you can either do this way or another method where you can actually alias this out. You can actually create an alias so that you know exactly which one it is, so you can shorten this code up at least. So what I'm going to do now is I'm actually going to back this out of here, and we'll just go ahead and hide this by commenting it out. And now when I run this code, we'll get the exact same functionality. So there's our Enter key and the OK button and the app exits. So there I have my class in the subdomain namespace. And then in the parent namespace, I have a similar method. It just shows you how you can actually organize these. You also notice that we have some additional things inside here. We have some references in here that we don't necessarily need. I can actually remove those two, for example, because we're not actually doing anything with them. We don't make any references or anything like that. And that's something that you probably want to make sure you do in your code. Clean it up nicely so that you don't have any extraneous references, lying around, especially if you're not going to need them. So that helps. Hopefully, that helps you understand how a C# application is actually organized and how the the namespace naming conventions actually work. In this case, I have the same namespace, and then I have a sub-namespace under it, and I can actually reference those in my code anytime I want. Now, one other thing I do want to point out is if this code was actually compiled into a separate DLL, in other words, it was a separate project, this class 1, you would have to add a reference to it and drill down in and find that reference inside of your either in your project or wherever it happened to be registered at. You might browse out to find the DLL that it's contained in. But we're going to get into that as a matter of fact, in the next week's episodes. So, all right, let's go ahead and go back over to our slide deck here. And interestingly enough, you're a quiet bunch. There are no questions in the queue. So this kind of wraps it up for today's session. We've got we covered what an assembly was and the namespace and how we organize those. And we can place our code, any code that we want to, into our own custom libraries and make it look integrated into the environment just like any of the system namespaces that come from the base class libraries are. Next week, we're going to go ahead and take a look at the actual program structure of a C# application, and we're going to see how an application is actually architected beyond just looking at the way we store everything inside of the assembly. We're going to look at the main function and how it's defined and how you pass parameters into it and things like that. And then we're going to look at the actual basic language and how the assembly, the intermediate language, and everything gets processed and interpreted by the system in order for it to do something meaningful for you while you're running the application. Now, I do want to thank everybody for coming and watching today. Please feel free to follow me on Twitter at WJSteele. Send me an email, wsteele@microsoft.com. Any questions that you have, feel free to ask me. Also follow, take a look at my blog, blogs.msdn.com/wsteele. We'll have all the code posted out there for all of this whole series, as well as the other webcast series that I've been doing, including the VB Soup to Nuts. And at this point, I'm going to go ahead and turn it back over to Sydney, where she can get you into the survey. Please fill out the survey. Let me know how I'm doing. Let me know how we're doing, what kinds of things you'd like to see in other webcast series, because this is what we do. Love doing it. Sydney?
Thank you. I'd like to remind everyone that you can print a PDF of the slides by clicking Control-P. You can either print or save those slides locally for your convenience. You should all be seeing a survey now in your slide area. If you could take a moment to fill it out before you log off, we do appreciate any feedback you leave for us. All you need to do is follow one of the 3 links provided to complete the evaluation. And with that, I'd like to extend a special thanks to Bill for presenting today. Thank you all for joining us. You may now disconnect from the audio portion of today's conference.